Hello again, students. So this represents part 3 and probably the last part in the series in which we'll figure out just some basic trig identities that come from rotations and reflections. So, because repetition is good, let's start by just reminding ourselves what went in this table so far. So, the first result says when you change an angle by 2 pi k, by a multiple of 2 pi, you don't change the trig functions. So cosine of theta plus 2 pi k is the same thing as the cosine of theta. The sine of theta plus 2 pi k is the same thing as the sine of theta. I swear a second ago the cats were being quiet, so they're being a little bit noisy. The cosine of negative theta is the same thing as the cosine of theta. The sine of negative theta is negative the sine of theta. And the pictorial reason why that happens is because this manipulation corresponds to a reflection over the x-axis. The trig function, if you change an angle by pi minus theta, what does that do? Well, if you draw a picture, you'll see that corresponds to a reflection over the y-axis. So what does that mean? That means the cosine of pi minus theta is negative the cosine of theta. Sine of pi minus theta is just sine theta. Changing an angle by pi plus that angle, so adding pi to an angle, well, that just changes a point on the circle by rotating by an angle of pi. So say this two different ways. This corresponds to a rotation of 180 degrees, or that's the same thing as a reflection over the origin. And what does that do? That makes the x coordinates negative, so cosine of pi minus theta is negative cosine theta. Sine of pi plus theta is negative the sine of theta. Sorry, when I said this, I may have said pi minus theta, but what's written is correct. Cosine of pi plus theta is negative the cosine of theta. So that leaves just these left. So what happens when you change an angle by adding or subtracting it from pi over 2? So let's get to that. There we are. So here it is pictorially. There's a rotation forward by an angle of theta. And if you want to think about rotating forward by an angle of blue, pi over 2 minus theta, well, here's one way of doing it. You can first rotate forwards by pi over 2, and then backwards by theta. So that means that, let's erase a lot of that, because now that we have this much, we'll be able to see something. So how could you transform this region into this region? Well, it looks like if you reflect over the line y equals x, that would do the trick, wouldn't it? So if there's the line y equals x, if you reflect over that line, then a point in this red region becomes a corresponding point in this blue region. So here are the angles of theta and pi minus theta. What reflection relates them? Well, reflection over the line y equals x. What does this do to xy coordinates? Well, it switches them. X values become y values, and y values become x values. So, summarizing this, if I want to know what the cosine of pi over 2 minus theta is, so that's this x coordinate, So that's the new x value. That's the x value after this rotation has been done. Well, how does that correspond to the old xy values? Well, the x and y values have just been switched. So that's exactly the same as the old y value. But the old y value, that's this. That's sine of theta. So cosine of pi over 2 minus theta is equal to sine of theta. Similarly, sine of pi over 2 minus theta, that's the new y value. After you do this reflection, though, that's the same thing as the old x value. But the old x value, what is that? That's cosine of theta. So the sine of pi over 2 minus theta is exactly the same as the cosine of theta. Let's scroll all the way up. So if you change an angle, if you replace it by pi, if you, instead of studying trig functions at an angle theta, you study trig functions at an angle of pi over 2 minus theta, the x and y values get switched because this amounts to a reflection over the line y equals x. Neato. So now going all the way back down, let's use that to compute other trig functions. So we know what cosine and sine do when you do this. Cosine of pi over 2 minus theta is the same as the sine of theta. Sine of pi over 2 minus theta is the same as cosine of theta. Maybe I'll do secant. Secant of pi over 2 minus theta is 1 over the cosine of pi over 2 minus theta. But what's the cosine of pi over 2 minus theta? That's the same thing as sine, right? That's 1 over sine theta. This becomes cosecant. So this action replaces secant with cosecant theta. Similarly, you'll find that it replaces cosecant of theta with secant of theta. Tangent becomes cotangent, and cotangent becomes tangent. Nice. So we can use this to do some computations. Let's suppose you want to know what the cosine of 3 pi over 8 is. Well, 3 pi over 8, well that's, if you draw a picture of it, right, that's like almost pi over 2, right, because 4 pi over 8 would be that, but then you go back by pi over 8. So cosine of 3 over 8 is the same thing as cosine of pi minus pi over 8. So that should be the same thing as the sine of pi over 8. And this is not a number that you should remember, but if you flip to a few pages earlier in this exact note packet, you'll find that we said the sine of pi over 8 is the square root of 2 minus the square root of 2 all over 2. Nice. And let's do the next one too. This, if you want the sine of 3 pi over 8, that should be the same thing as the sine of pi over 2 minus pi over 8. But that's the sine of pi over 2 minus an angle. The sine of pi over 2 minus any angle is the same thing as the cosine of that angle. And again, that's not a number that you should remember, but if you flip back to earlier in this document, you'll see that that's the square root of 2 plus the square root of 2 all over 2. So there's only one identity left, one thing left on that cover page in this note packet. I want to know what happens when you think about trig functions at pi over 2 plus theta. And there are two different arguments that we could go through. And if this were a class limited by things like time constraints, I'd make you guys pick one of them, and that's the one we would talk through. But I have no way of asking you which one you want. And I don't necessarily have that same time constraint. You're probably watching me at double speed or something anyway. So let's use previous identities to express the cosine of pi over 2 plus theta. And here's the idea that we'll use. If I want to compute the cosine of pi over 2 plus theta, well, I can write plus theta as minus theta. So here, I'll add some color coding in. If I want to compute the cosine of pi over 2 plus theta, I'll instead compute the cosine of pi over 2 minus theta. there's that color coding. You know what? I think it would be better to highlight. So I'll make this bit red. But now if I just treat this bit in red, like it's a variable of its own, right? Now I'll just put it in a red box. Well, then I see the cosine of pi over 2 minus a red box. I know what cosine of pi over 2 minus a thing is. The cosine of pi over 2 minus a thing, cosine of pi over 2 minus a thing is sine evaluated at that thing. So I can express cosine of pi over 2 minus a red box as the sine of whatever is in that red box. And what is in that red box? Well, negative theta is in that red box. So now you should ask yourself, what's the sign of negative theta? Well, by looking at the top, at that cover page where all of these identities are written, sine is an odd function, so the sign of negative theta is exactly the same thing as negative the sine of theta. So it's the cosine of pi over 2 plus theta. It's exactly minus the sine of theta. We can do the same thing. Oh, okay, so that's 2 lines done all in 1 line. That's okay. Let's do the same thing to compute the sine of pi over 2 plus theta. So we'll do the same thing. The sine of pi over 2 plus theta is the same as the sine of pi over 2 minus theta. And for emphasis, I'll again put this bit in a box, which I'll even shade in. So now what do I see something that in this line that looks like the sine of pi over 2 minus a number. Well, the sine of pi over 2 minus a number is the same thing as the cosine of that number. So using that fact, the sine of pi over 2 minus a thing in a red box will be exactly the same as the cosine of the thing in that red box. And what is in that red box? Well, negative theta is in that red box. So the sine of pi over 2 plus theta is exactly the same thing as the cosine of negative theta. Carrying on, what's the cosine of negative theta? Well, if you flip to the cover page, that top page in the notes, you'll see that the cosine of negative theta is exactly the same as the cosine of theta. And again, this is like 2 lines for the price of 1. So, that's everything. That tells me what the cosine of pi over 2 plus theta is. It's negative the sine of theta. And the sine of pi over 2 plus theta is, it's cosine of theta. So let's fill those in on that top page. The cosine of pi over 2 plus theta is negative sine theta. The sine of pi over 2 plus theta is the same as the cosine of theta. And that was a purely algebraic technique. There was no geometry. All we did is we used algebra. But trigonometry is built on top of geometry. So there should be a geometric argument. And here is that geometric argument. So maybe I'll draw the warm-up picture right here. So I want to understand an angle of pi over 2 plus theta. Let's draw an angle of pi over 2 plus theta. If I want to draw an angle of pi over 2 plus theta, I should first draw an angle of pi over 2. So it's a right angle, and then an angle of theta. Then this angle is an angle of pi over 2 plus theta. Neat. So let's compare that with what I would get if I just drew an angle of theta. And I'll try to do my best to make everything look like it's actually the same size. So that means I'm just going to start here and go forward an angle of theta. So if you look at these 2 pictures, just for emphasis, this little wedge has an angle of theta. I'm saying wedge when I mean sector, right? We have a name for this shape. Those 2 sectors are exactly the same size, they're just in different quadrants. So I can interpret that as implying, wrong button. that this triangle and this triangle are exactly the same triangle. Well, they're not the same triangle. They're congruent triangles. All of the sides have the same length on either of those triangles, and all of the angles are the same. So let's use that. So let's label the sides. So it looks like the base of this triangle, this length, is exactly equal to cosine of theta. The height of that triangle is exactly the same as the sine of theta. And maybe I'll decorate these with this one with a single dash, this one with a double dash. So, over here, I see that this side length is the same as the one that's labeled as double dash on the other side. And this one is the one labeled as single dash. So that means that this distance must be exactly the cosine of theta, because that's what single dash was labeled as. Maybe I'll even put an arrow on it. Whereas this distance is the sine of theta. So reading that off, that should mean that the sine of pi over 2, I'll do sine first, plus theta, well, that's the y-coordinate. That's this y-coordinate. What does a y-coordinate mean in the picture? It's how far you go up to get to that point. How far did I go up? Well, I went up by exactly cosine of theta. So the sine of pi over 2 plus theta is cosine of theta. Now let's think about cosine. So cosine should be the x-coordinate. So the x-coordinate is how far to the right do you go? Well, it looks like you don't go right at all. You go left. Well, that means you're traveling in the negative x direction, a length of sine of theta. So this x-coordinate is exactly negative sine theta. So cosine of pi over 2 plus theta is negative the sine of theta. Nice. And I think I won't talk through these numbers. I'll leave those for you. I'll write down what the end result should be. So secant of pi over 2 plus theta is the same thing as negative cosecant theta. Cosecant of pi over 2 plus theta is the same as the secant of theta. Cotangent is negative tangent. Tangent becomes negative cotangent. Cool. So there's one last thing that I think I want to touch on, and it's something that should be relevant to you, because this will be reflected in the homework. So these 615 problems are homework problems associated with today. And I'm double checking right now which one is the one that I am actually having you do. So you can check this on your own. That's the one that appears on Canvas. So I won't do that one right here. So let's try to compute some of these trig functions. So I think I'm going to hit this one because it will be important for the rest of them, and it's an important idea. So let's try to compute the sine of alpha. Well, we have a plan of attack, right? If you know what the cosine of an angle is, how do you determine the sine of an angle? Well, you use the Pythagorean identity. I know that no matter what the angle alpha is, the cosine squared of alpha plus the sine squared of alpha always adds up to 1. And now let's use the givens. I am given that the cosine of alpha is 3/5. So that means it should be that, parentheses, 3/5 squared plus sine, you know what, I'm going to be lazy. S squared is equal to 1, where S equals sine alpha. So this way I can avoid writing sine of alpha all the time. So apparently I want to solve for S. I want to know what sine of alpha is, and S is the sine of alpha. Let's do that. 3/5 squared, square the top, you get 9, square the bottom, you get 25, plus s squared is equal to 1, which I'll go ahead and write as 25 over 25, because I'm about to do some subtraction. I need to subtract 9 25ths to the other side. S squared is equal to 25 over 25 minus 9 over 25. 25 minus 9 is 16 over 25. Oh, neat. So that means that s is plus or minus the square root of 16 over 25. Are there any perfect squares in that square root? There are. 16 is a perfect square. And 25 is a perfect square. So s is plus or minus 4/5. Let's decide if it's plus or minus. So how do you think about that? You need to know what quadrant this angle is in, I guess? But that's given. This angle lives in the first quadrant. In the first quadrant, sine and cosine are both positive. So sine of alpha is plus 4 over 5. So let's finish that. That means the sine of alpha is 4 over 5. So to do most of these problems, it's just a matter of appealing to some of the results that we've done in the notes already. If you want to know what the sine of pi minus alpha is, well, if you remember from if you look at the cover page, the sine of pi minus theta is exactly the same as the sine of theta. So the sine of pi minus alpha is the sine of alpha. And what is the sine of alpha? It's 4/5. So just do that basic procedure a bunch of times. So you'll notice that at no point in the notes have we talked about an angle of 3 pi over 2 plus or minus a number. Well, that's not so hard to walk out, right? 3 pi over 2 is the same as pi plus pi over 2. So if you want to know what the cosine, I'll do cosine, of 3 pi plus pi over 2 is, here's what you can do. You can write that as cosine of pi plus pi over 2 plus alpha. And addition is associative, so it doesn't matter how you arrange parentheses in there. So I'll put this in a red box, same as I did in some of the examples in the notes. I'll even highlight it, not that the highlighting is important, but it's easy for me to do, so I do it. So now what do I see here? I see something that looks like cosine of pi plus a quantity. Well, how does cosine change when I add pi to it? Looking at that cover page, adding pi to an angle corresponds to a flexion across the origin. So the x and y coordinates will both become negative. This is the same as negative the cosine of whatever that number is. So the cosine of pi plus a red box is exactly negative the cosine of whatever is in that red box. And now I'll put the thing that belongs in that red box, pi over 2 plus alpha. So now, for the sake of emphasis, I'll color code that negative sign as a green negative sign. So let's continue this. So this is equal to negative sign. And now I see pi over 2 plus alpha. So look at that cover page. Cosine of pi over 2 plus a number is negative the sine of that angle. Alright, so now we're done. The cosine of... Well, no we're not. There's still some simplification to do. So that means the cosine of 3 pi over 2 plus alpha is equal to negative the negative of the sine of alpha. Well, those signs cancel, don't they? That's exactly the same as the sine of alpha. But let's go all the way up. What's the sign of alpha? It's 4/5. Cool. So, now just do that same thing for problems 10 through 13. They should all be reasonably straightforward. Do that and shoot me some questions. I'll talk to you later.